Prove that the resultant of 5 forces, AB vector, AC vector, AD, AE and AF vector, acting at the vertices of a regular hexagon ABCDEF is 6 times AO vector, where O is the center of a hexagon. Let us begin. So here we begin by considering a regular hexagon. Let's name the vertices as A, B, C, D, E and F. We also have the center of the hexagon at O. Now, let's name the side. So here we have AB vector. Then we have AC vector. That means we need to join vertex A and C with a directed line segment going from A to C. Next, we have AD vector. So AD vector means we'll draw a directed line segment going from A to D, and A vector will be another directed line segment going from A to E. And we have AF vector. So we'll begin by first summing up AV vector with AC vector, with AD vector, AE vector and AF vector. Fine. Now we have to show that this sum up to 6 times AO vector, where O is the origin of the hexagon. Now here, if we look at the vector AF, the AF vector will be exactly equals to the side CD because it's a regular hexagon. So let's assume that we have a directed line segment going from C to D. Yeah, we are saying here. So we can rewrite our resultant as AB vector plus AC vector plus AD vector plus AE vector added to. Now instead of AF vector, we're going to write CD vector. So here we have used the fact that AF equals to the vector AF equals to the vector CD. Fine. The reason why we did this, now what we'll do, we'll be combining AC vector with CD vector. So we write it as AB vector added to AC vector plus CD vector, and the remaining vectors AD vector plus AE vector. So here, what is the vector AC when it's added to the vector CD? So we have AC vector added to CD vector. So that's going to give us the vector AD. That's from the triangular law of vector addition. So here we have AB vector plus AD vector plus AD vector plus AE vector. Fine. So we have used the fact that AC plus CD, when you add these two vectors, that becomes equals to the vector AD. Fine. So that means we now have 2 times the vector AD added to. Now we have AB vector and we have AE vector. However, AB vector, so that the side AB of this regular hexagon is going to be equals to the side ED. So what we'll do, we'll consider ED to be a vector going from E to D such that AB vector becomes equals to ED vector. So in its place of this AB, we can replace it with ED. So here we have ED vector added to AE vector. We have used the fact that AB vector equals to ED vector. Now we have ED vector added to AE vector, or in other words we can say we have AE vector added to ED vector. So from the triangle of vector addition, this will be equals to AD vector. We have 2 times AD vector plus AD vector. So here we have also used the fact that AE vector when added to the vector ED, that becomes equals to the vector AD. Fine. So that means now the resultant reduces to 3 times the vector AD. However, O is the center of the regular hexagon. If O is the center, we can also say that O is the midpoint of the vector AD. In other words, we can say that AD vector, this will be equals to 2 times AO vector. Now let's replace AD vector with 2 times AO vector. So we get 3 times 2 times AO vector, and that's going to give us 6 times AO vector. And this proves a problem. So we have showed that the sum of the 5 forces AB vector, AC vector, AD vector, AE vector and AF vector, thus equals 6 times the vector AO.